Today in algebra we started learning about finding the greatest common factor. In part A we started with the number 60 and we broke it down into its prime factorization. In this case I have 2 times 3 times 2 times 5. The other number is 33 and I want to figure out what the common factor of 60 and 33 is. 33 is 3 times 11. The greatest, or the factor that they have in common is 3 and there isn't anything else they have in common, so the GCF is 3. Let's look at a few more examples like that. If I have 15 and 25, I could break 15 down into 3 times 5 and 25 down into 5 times 5. The common factor is 5, and it's the only one, so the GCF is 5. What if I look at something with some variables in it, like 3x to the third and 6x squared? 3 is 3 times x to the third, and x to the third would be like x times x times x. 6x to the third would be like 6 times x squared. X squared would be x times x. 6 would be 2 times 3. The things they have in common are 3 and then 1, 2 x's. 1, 2 x's. So my GCF is 3x squared. Does that make sense? The next section we want to do is to factor using the GCF. To do this, we're basically going to think of reverse distribution. Reverse distribution. Okay, looking at example number 4. If I have 4x squared minus 3x, I'm going to write out both of my terms, 4x squared and negative 3x. I really don't need to do the negative because I'm going to put that back at the end. But here I could do my prime factorization. 4 is 2 times x, and 3x is 3 times x. I'm going to circle what they have in common, which in this case is x. What they have in common goes on the outside. What is left over goes on the inside. So what's left over here is 2 times 2, which is 4, times x, which would be 4x. The sign in between was minus, so the sign in between here is minus, and what's left here is 3. And that would be my final answer, my factored form. If I distributed back x times 4x is 4x squared, and x times negative 3 is negative 3x, that's a good way to check my answer. Let's look at another one like that. 10y to the third plus 20y squared minus 5y. Okay, I'm going to write out my terms. And I'm going to do their prime factorization. So for 10, I have 2 times 5 times y times y times y. For 20, I have 2 times 2 times 5, because 2 times 2 is 4, and 4 times 5 is 20, times y times y. And for 5, I have 5 times y. They have in common, every single one has a 5. Every single one has at least one y. So I have 5y. What's left is 2 times y, which is 2y squared, plus, because this sign's plus, 2 times 2 is 4y, plus, or minus, because that one's minus in between. There's nothing left here. When there's nothing left, I write a 1. The reason that I do that is so that when I multiply this back out, 5y times negative 1, I would get negative 5y. That's really important. Don't forget that. If nothing's left, you put a 1. Okay, let's look at a few more examples. Before we do that, I'm going to give you the steps. Number 1, find the greatest common factor. Number 2, pull out the GCF of each term. And step 3, write the remaining terms in parentheses. Okay, let's look at some examples. Number 6. If I have 5b plus 9b to the third, is there a number that goes into 5 and 9? No, there is not. Is there a b here and a b here? Yes. So b is what they have in common. Now, if I take a b out of 5b, I took one b away, I'm left with 5, plus sign in between, I'm left with the 9, and then if I had 3 b's and I took out 1, I now have b squared left. And that's my factorization. Let's try just a few more. If I have 8x to the fourth plus 4x to the third minus 2x squared. Okay, as far as the numbers go, what goes into 8 and 4 and 2? That's 2. What goes into x to the fourth, x to the third, and x squared? Well, there are 4, 3, and 2. The most they have in common is 2. So I have 2x squared. That's the most they have in common. Okay, 2 times what gives me 8? 2 times 4 gives me 8. I had 4, I took out 2. I've got 2 remaining. Plus, 2 times what gives me 4? That'd be 2. I had 3, I took out 2, I have 1 remaining. Minus, I took out that whole term. I took out the 2, I took out the x squared, so it's a 1. And that's it for that one. Again, if I wanted to distribute in my head, I could do that. 4 times 2 is 8, 2 times 2 is 4, 2 times negative 1 is negative 2, and that kind of double checks for me. The last one we're going to do, we want to deal with some negatives. So if I have negative 5g to the third minus 15g squared. Notice that this first one has a negative. When that happens, I'm going to pull the negative out. And if I have 5 and 15 in common, the number that goes into 5 and 15 is 5. They also both have at least 2 g's. Now, if I took out negative 5 from negative 5, the number part is 1. I had 3 g's, I took out 2 g's, that's just a g. That looks like a negative, it's not. So 1 g is left there. I took the negative 5 out of 15. Negative 5 times what gives me 15? That'd be positive 3. I had 2 g's, I took 2 out, so that's it. I could rewrite that as negative 5g squared times g plus 3. And that's my prime factorization. Your assignment is A6, and that's page 535, numbers 1 to 10. It's really important that you learn this and understand it, because tomorrow we're moving on to a new concept. Good luck, and let me know if you have questions.